You're in the water loop.
Welcome to Waterloop, the nonprofit news outlet exploring solutions for sustainability in water. I'm the host, Travis Loop. Wastewater treatment plants rely on non-stop mechanical power, gearboxes, bearings, motors, and couplings that keep pumps, aeration basins, bar screens, and clarifiers running around the clock. In this episode, Dave Zimmerman of Dodge Industrial explains how powertrain reliability underpins every stage of treatment, from moving water to driving oxygen and handling solids. He highlights opportunities to cut energy use, reduce maintenance, and support utilities facing workforce shortages. Dave also discusses emerging technologies like real-time sensors and predictive monitoring that are reshaping how facilities manage performance and extend equipment life. Before starting the conversation, I want to share 1 minute about this episode's sponsor, Dodge Industrial. If you value Waterloop content, please connect with the sponsors that make it possible. As wastewater plants face rising energy costs and workforce shortages, Dodge Industrial unveils game-changing power transmission solutions to keep systems running smoothly. The motorized torque arm powers aerators, mixers, and pumps with a rugged, shaft-mounted design built for high shock loads and 24/7 operation. It doubles bearing life compared to alternatives, slashing downtime and maintenance costs. The Raptor coupling complements it, isolating misalignment to ensure seamless performance in demanding environments. Integrated with Optify performance sensors, the motorized torque arm provides real-time vibration and temperature data via cloud-based alerts, enabling predictive maintenance to optimize performance and extend asset life. Trusted by utilities for energy savings and durability, Dodge empowers wastewater systems to operate efficiently and sustainably. Learn more at dodgeindustrial.com.
To start, I'd really like to hear about a powertrain, what this is. When you look inside infrastructure at a water plant, what is a powertrain? What are all the pieces there? And why is this also important?
So if I was to describe a powertrain, it's really the system that's required to move something from point A to point B or rotate a shaft, right? So we're looking at all the different components. From the start of it, you're going to energize the system with an electric motor a lot of times. And then you're going to turn that energized movement down. You're going to amplify the torque through a gearbox. You'll support that shaft that the gearbox is driving with bearings. And then a lot of times you'll put couplings in between. So collectively, as a whole, that's what we would consider the powertrain process.
At these wastewater facilities, kind of continuous operation, having power all the time is super critical. Could you talk about that a little bit? That power transmission role at a wastewater treatment plant. What does that power do? Why is it so critical?
Yeah, I think if I was to step back and take the power transmission side of things, one layer deeper, there's a lot of things that need to come together in a wastewater treatment plant. The teams of people that really build out and design and engineer and then operate a treatment plant come from multiple different places. We happen to touch a little bit of each one of them, but we're true experts on the mechanical side of things. That's where we really add value throughout the ecosystem. It's our ability to drive and deliver torque to an application consistently and just repeatedly. Like you said, these applications run 24 hours a day. They're always running, and we need to be able to be a dependable solution to some of these customers.
What are the environmental challenges in a water facility, especially for powertrains? What's challenging about the conditions?
Well, inherently, just being in a water environment, humidity and moisture are going to be a big factor there, right? You're gonna deal with two things when you're in an outside environment, predominantly the humidity piece, but there's also the ozone that comes from the sun, the direct exposure from the sun. On our coupling line, we've put an armored protection over some of our rubberized components to be able to withstand that, the breakdown from the sunlight. But when I think about water, the real way you want to understand that system from the whole entire powertrain is how can we keep moisture from coming inside? And one of the things that we do, we really spend a lot of time working on the sealing. We've developed a ton of R&D around sealing technology and being able to keep barriers, preventing that moisture from coming in. But one of the more interesting things that's happening in the industry now is people are looking at ways where they can automate the maintenance of that product, right? So where they can bring in fresh lubrication without having to have it be part of their PM system. And there are solutions out there that are automatically dispensing that, and they're able to then project that out and collect the data of what they're doing and be able to report that back to their facility, across the facility, I should say. And that's adding a lot of power to what customers are doing right now.
And what happens with these harsh conditions, the moisture or the sunlight?
Right.
What failures happen, if that's not taken care of?
Well, the sunlight can break down a natural rubber, so you'll start to see a premature failure of a coupling if that's directly exposed there. On the moisture side of things, if you get any moisture inside of a gearbox or a bearing, you'll start to see rust. The components will start to rust. That rust will then turn into something else inside. It'll start to circulate around the gearbox itself within the oil. The rust will circulate throughout the oil and eventually get caught up in some of the internal bearings, the moving components. And you could eventually see, catastrophic failure from that if you don't.
Yeah. So kind of paint a picture for me. Tell me, imagine a facility. Talk about where that power's going, what it's powering, what those things are doing.
Yeah. So in any wastewater treatment facility, there could be a demand for a rotating shaft. That's what we specialize in, right? We're going to turn a shaft. We're going to consistently either connect that shaft to another piece of equipment or drive an application, a specific application. And one of the areas that you'll find in a wastewater treatment plant, there's a lot of blowers, there's a lot of pumps, there's a lot of oxidation ditches, clarifiers, bar screens. They will all need those rolling elements, the bearings, the gearboxes to drive them. We're going to be able to help with that side of it, not the biological side of it, but the mechanical side of it.
Yeah.
I think there's a real need in the market for that, for customers to be able to be supported, not just on the actual effluent that's coming through a plant and the way it's being treated, but who's going to make that system turn and roll over.
A lot of power is used by water treatment facilities. They can often be one of the biggest energy users in a city or a town, right? What kind of analysis is out there about that energy use, and then especially the opportunity to be more efficient?
Yeah, really, when you look at anything in a wastewater treatment plant, it's going to operate 24 hours a day. So that energy demand is consistent throughout the day. I mean, there's peaks and loads to anything that happens as far as the amount of water coming through a facility, but you need to keep it turning, right? You need to consistently be able to deliver clean water to your end customer or your municipality, the community itself. When we step back and look at that, you add up multiple different instances where a pump over here, an oxidation ditch over here, you've got a 40 horsepower motor, a 60 horsepower motor, or redundant versions of all of those. You can add up to some serious power draw on a system like that as you continue to operate it throughout its day points. We've looked at different designs and been able to optimize certain aspects of that system by bringing in Dodge technology and some of the solutions that we have to eliminate between 7 and 10% of their energy draw, which when you dial that in and you look at, even at 7 cents a kilowatt hour, when you're running 24 hours a day, 365 days a year, that adds up into real money. And we're seeing customers really resonate with that lately.
Is that a focus really for a lot of facilities and utilities now, is like, how can we bring this power bill down?
It's definitely a component of it, right?
Yeah.
They want to look at multiple different things. One of them is the serviceability of their equipment. So they want to be able to have it work and deliver dependable operation. But they also, when they need to change something like a car, when you're driving your car, you need to change the oil, you need to do certain things to your industrial equipment. It needs to be serviceable. You want to have it be as low of an energy draw as possible. So the efficiency standpoint is definitely there. And we're seeing a huge message these days around safety as well, making sure we're putting solutions out there that are delivering a safe operating environment for the end customers. Yeah.
Yeah. Well, speaking of the people at the facility, right? Workforce is always an issue in the water sector. Having enough people, the right people to run operations. There's a lot of retirements happening right now. So I know utilities and facilities are looking at how can we deal with those workforce challenges. What role can equipment like this play in that?
Yeah. Well, first of all, you're absolutely right. The trends are going in a direction where there's less and less experience in the world. And we're trying to take our application experience, if I can package that 100 years of experience together into a box and deliver that to a customer almost literally out of the box, right? To be able to have them install a bearing that has an inner unit that's already pre-built and preset for any type of environment. But the wastewater industry is one that's what's relatively unique because of the fact that there's so much moisture, there's so much environmental potential contamination around that if you were to do the traditional path, which is take a spherical roller bearing and have the top of it come together, you put the rolling element in, you have to put the feeler gauges in, you have to set the bearing in place, the sleeve nut and lock washer have to come together. You're exposing all those internal components now to a lot of different contamination. Moisture could, ultimately make its way in there. And in the wastewater world, that's a real variable. So what we're doing is we're pre-engineering that. We're building it at our manufacturing plant in a controlled environment and being able to deliver it to a customer where it's easy to install, but it's also pre-packaged into what we call an inner unit that's pre-designed for the application. So that's just one example. I mean, that's on the bearing side of things. We cover the entire powertrain, right? So all the way from the motor, all the way down to the bearings, the gearboxes, the couplings in between, throughout the powertrain, we're going to be able to deliver a solution that's going to add some value along the way. And that bearing example was one. The other thing you want to really focus on when you're looking at products themselves is what's it going to do in the long term as far as, circling back to that usability, the maintenance side of it.
Maintenance, right?
Yeah.
That's a big deal.
Yeah. Being able to remove it. I mean, these treatment plants are in the middle of nowhere. A lot of times they're in a very rural area, I should say. And there might not be enough equipment to pick everything up or to move everything around. So having a piece of equipment that's going to be designed to be able to come apart easily and have a shaft drop out and be able to pick up half of the shaft or remove something can be very powerful.
Reliability factors into maintenance too.
Sure.
We were talking about how some of these pieces will run for 30 years, 24 hours a day, which is just amazing, right? Think of all that happens in that time. So reliability helps with, lower maintenance, lessen that workforce pressure, right?
Yeah, 100%. And one of the things that we've designed to tie together the concept or the theme around others that aren't, the industry itself is as an employment situation where there's not as many people that are as skilled as they once were. We're designing in some features from a reliability standpoint that are going to drive a message and hopefully be able to build out a user experience that's going to really resonate. We've put in visual indicators throughout our products. On some of our gearing products, on our reliability kit, we'll have a sight gauge where you can actually see the level of the oil or even the quality of the oil. We have oil sampling quartz that will be able to take something out of it easily to measure it and to channel that data back to the operator and figure out if the gearbox is in its right operating condition. We've built quite a bit into the whole system and being able to easily do these things as far as even as something as simple as putting a drain on a gearbox where you have to change the oil out. It allows that to happen at ease and you're able to pull the oiled oil out and put the new oil in.
Could you talk about the other sectors that Dodge works in and how working in those places has benefited what you're doing in the water industry?
It's a really interesting idea. We were really strong in the aggregate space and in the grain handling in those two industries specifically. But when you double down and you look at the aggregate industry,
what is the aggregate industry?
That's rock, any type of mining, type rock crushing. When you're pulling something out of a quarry, think big industrial equipment, conveyors that are moving some type of aggregate product from point A to point B. Well, in that process, you're going to see a lot of things be disrupted, right? There's going to be a lot of shock load sometimes that gets caught up in one of those systems. When you're trying to move a lot of rock, limestone, whatever type of sand, whatever it is. It can get
heavy, hard stuff.
Heavy, hard, real, truly heavy and hard.
Yeah.
That type of equipment will at times be overloaded, right? You hit an overload, you're going to send a shock load through that system and potentially bind everything up. And so where that plays into the water industry, if you can design a system that can handle that momentary overload, you're going to design a system that are going to be able to deliver a system that in an environment like water or wastewater that isn't maybe as shock load dependent, but still needs the life cycle dependency of something, you're going to be able to deliver that same performance or even more because you're not seeing those peak loads and all the different shocks coming out of it. So what we did specifically to address that, we worked from the inside out of some of our components. So on our gearing, if you were to look at a gearbox, a lot of gearboxes look the same across the industry, right? We're case carburizing and grinding the gears on the outside. So we're putting a really hard shell to the outside of our gearboxes, our gear teeth, I should say, but a real ductile core on the inside. So we're inducing some carbon atoms to allow that process to happen. And in doing that, you're able to deliver an extended life in any type of environment. And water and wastewater, we're finding to be a really good one, right?
Technology is always evolving, equipment's always evolving, materials and everything. What's kind of happening now in this space, or what might be coming up in the near future if you pull out your crystal ball, just kind of when it comes to the evolution of all this?
The crystal ball.
Yeah. Putting pressure on you.
Well, one of the things that we're seeing a lot of people really look at and have interest in and start to even roll out in different applications is some sensor technology. So being able to have somebody come in and be a second set of eyes or a monitoring system that's going to take consistent measurements throughout a day and be able to deliver that and store that data and give you not only a real-time look if there's anything wrong with your system, but a historical look as how is this operating? What's the true life of this? What's the health of this system right now? And we're seeing that really play out in spades at a lot of different customers. And the neat thing about that is we're able to look at the data sets coming out of whatever it is. If it's a gearbox or if it's a bearing, we can put a vibration and temperature monitor on there where it can capture a signal every 15 minutes, every hour, however you want to set it. And then you can start to see trends. And it's that trending data that tells you over a long period of time. We started talking about 30 years, right? You don't see anything in 15 minutes when you're looking at a 30-year window. But when you look at that over time, you can really start to see some unique signs of what is the health of this equipment and what can I do to extend it. And that data has proven to be really exciting for us right now.
A powertrain at a water facility, it's still that kind of same setup, and it's pushing processes along. There's a lot of different parts of a water plant that use powertrains or...
Oh, absolutely. Okay. Yeah. Anytime you're trying to drive a process, whether it's moving water or even maybe driving oxygen into the water, or you're trying to aerate something from below or skim something off the top, or even take a conveyor and auger and a screw conveyor and pull something away and stack it somewhere else. That's all happening through some level of a powertrain, right? You're having to start with energy, turn it into a rotational force, multiply or amplify the torque with a gearbox, support it with bearings, and deliver it to whatever your application is going to ultimately need.
Could you talk about how powertrains can be made more energy efficient as these facilities are trying to bring down that utility bill?
Yeah. Well, one of the things you can do is really look at the way, and looking at gearboxes specifically, right? You have an efficiency loss within a gearbox, let's say. And any type of gearing, whether it's helical, you lose 1.5% per stage within the gearbox itself. Different types of gearing will have different versions of that. But we can look at the way you're energizing that gearbox and the way that the motor power is connected to the input of that reducer or that gearbox. And if you simplify that drivetrain, maybe remove the belt and the sheave from slipping on the input of that, you can pick up that 7 to 10% efficiency gain right there. And that's where I think really trying to understand where's your power going from the beginning all the way to the end, and finding a solution in between that's going to be energy efficient. That's the way to look at it.
Thanks for listening. If you want to support Waterloop's ongoing exploration of water solutions, subscribe on YouTube, rate and review the podcast on Spotify and Apple, follow us on social media at The Waterloop, and sign up for email updates at waterloop.org.
You're in the Waterloop.